So we have to find the equivalent resistance of this whole block, this whole thing. What it's actually trying to say here is current is going this way and coming out that way. So if we make an observation, this one, let's call it node 1, node 2 and node 3, these three. So 3. So there is a delta connection here. You can see this one is a delta arrangement here. So we can do this delta Y transformation here. So N1 will be here. So this is the neutral. This will be N2 and this will be N3. So now N1 this one, N2 this one, N3 this one. And what happens is these three are replaced. So after N3, R5 is connected. So R5 is going there. This is R5. And here from N1, which is here, N1. From N1, R4 is going, is connected to the end of R5. That's how it is. So this one is R5. And finally this resistance, I will just draw like that. This resistance is R6 here. So if I call it RA, RB, and RC, RC, from Y delta transformation, RA will be, it has from to N1, R1 and R2 is connected. So R1, R2 over R1 plus R2 plus R3. So it's common everywhere. Similarly, RB will be, RB is this one which is connected to N2. So R1 and R3 is connected to it. So it is R1, R3 over the same thing here. And then finally RC, which is this one which is connected to R2 and R3 are connected to that in the delta connection, R2 and R3. So like that, and then the same R1 plus R2 plus R3 like that, it's coming here. So I'm not writing those things. So this is the new arrangement now. We still have I1, I2 going that way. So yeah, the R1, RA, RB, RC, which is the Y equivalent of the arrangement, delta arrangement, can be found from there. So I will erase this part, and so the final thing is here, which is, so now we can see that if we look at it, this RB plus R6, this is coming in series, and RC here and R5 is coming in series, and these two are parallel. So basically RB plus R6, this is in series and it is coming in parallel to RC plus R5. Now this whole thing, once this equivalent resistance is found, this is coming in series with RA. So RA is going in series with this whole arrangement here, these two parallels, and finally this one is R4 here. This whole part is in parallel with R4, and that's the equivalent resistance. So this whole part is in parallel with R4. So R4 is this one in parallel with RA plus these two RB and R6 plus let me use another color now. So RB and R6 are in series, and those series arrangement is in parallel with RC, R5, which are in series as well, and that equivalent resistance is again in series with RA, and that RA and this series parallel thing is coming again in parallel with R4. So that's the equivalent resistance. The ultimate equivalent resistance is this thing. R equivalent is this R4. So when a battery connected to it, it will be something like this: RA here, and then this thing, this thing, this thing, this thing, and this whole thing is again connected with R4, and this is I1 here, and this is actually I1, both has to be I1. So in the question also this is also I1, the same current has to come back, unless it can be different if this is just part of the network, so we don't know. If it is the same current, the battery is connected here, but if it is a different current, we know there must be something else in the network, so that it's not the same thing that's coming to the battery. But that's not the issue here. We just need to find what is the current resistance that can be seen here. So looking at that, so anyway, since it was I2, we can assume that something else is connected. So basically, yeah, so basically this is RA now, this is RB plus R6, this is RC plus R5, and this is R4. That's how it is. That's what this one is.